All right, now let's do the GPCRs and vision. Why not, right? Why not? All right, so, yeah, let's go. So start with a nice little orange sunshine up here. Looking good. And the sunshine is going to send off photons, which are going to be little packets of energy. And I guess we can title this GPCRs and vision. There we go. Okay, photons are going to come out, and the photons are eventually going to hit this guy, which is going to be our GPCR. So 1, 2, 3, 4, 5, 6, 7, and 8. And we can make a little helix, a little squiggle there. And if I had thought of it at the time, I would have just drawn it that way. And so there's number 8 down there. There we go. Looking good. Okay. And so this is our GPCR. So this is, let's say this is rhodopsin today. Or a photopsin. And inside of this molecule, we're going to put a, let's see, 11 cis retinal, which has got a little ring in it, and it's got a little bend in it like that. And we're going to pop out a the old all trans retinal. Remember, it's retinal with an AL at the end. Okay, so now we're going to have this thing loaded up, and here, let's actually make this red so we can see where it is. 1, 2, 3, 4, 5, 6. Oops, 5, 6. There we go. There we go. That's about right. Okay, and so it's going to be inside of here, about like that. Yeah, I don't like messing up my markers, but so be it. Okay, the photons from the sun are going to come in. Boom. The top of the protein is actually going to act, it's got a couple little bits up here, it's going to act like a lens. So it's a protein lens, which seems weird, but yeah, everything's a little weird when you get down to very small sizes. And so we're going to actually focus that light down onto our molecule. Actually, we're going to focus it right on that bond in the center of the molecule. So that's a better spot to draw it. There we go. All right. And so once that has happened, then we're going to have a change in the molecule. So we are going to still have 1, 2, 3, 4, and then 5, 6, 7, and we're going to move this one a little bit. So let's see. Number these 5, 6, and 8. And alpha helix 5, 6 because it's attached to 5, and 8 are going to be rotate. Rotate so that the cytoplasmic side is going to move outwards. Yeah, so let's rotate cytoplasmic domain outward. Yeah, all right. And the reason why that happened is, of course, because our little molecule here has turned from an 11 cis retinal to an all trans retinal. So photon converts 11 cis retinal to all trans retinal. There we go. Fine, and that's why this other thing happens. So there, then that happens. Great. And now that we have changed the position of 5, 6, and 8 in particular, we are now able to work on the G protein. So rhodopsin is photopsin. These are GPCRs. That's a good thing to put in your answer, just so we know. Yeah, because we all know, but just so it's there. Okay, and a GPCR is nothing without a G protein. So here, let's make our G protein. Let's make it blue. So, whoop, that's green. There we go. Okay. So here is our G alpha, and then here is our beta, and here is our gamma. Gamma's like a banana. Gamma banana wraps around the beta. Yeah, kind of structured. So gamma, there we go. That's fine. And our G alpha subunit is, of course, holding on to a GDP. So this is G protein with GDP, which is inactive. All right, so now let's make it active. So because we have changed the shape of this, it's going to act like a can opener or a pry bar or whatever. It's going to pry that GDP out. And now we're going to break this apart. So let's see, the G alpha exchanges GDP for GTP, and G beta and gamma will leave G alpha. And they'll go off and do other things, and we don't need to worry about those other things right now. Yeah. All right, so looking good. So let's now draw what happens to this. So we'll move it over here, draw it, and so we've got our, there we go. We've got our G alpha, and we'll make a nice little notch in there where we can put our GTP, because we've exchanged GDP out and GTP in. I drew the arrow backwards, but the arrow head tells you which way it's going. So there we go. All right, so we got GTP in there, great. And so now this is the G protein alpha subunit with GTP, and it's going to be active. All right, and so what's it going to activate? Well, let's go over here and see. So here we've got Mr. Cyclic phosphodiesterase. So cyclic phosphodiesterase. And this one has an alpha subunit, and this one has a beta subunit. Actually, we should draw this a different color. Let's make this one green. So there we go. We've got our alpha, we've got our beta, and we've got our two gamma subunits. Gamma and gamma. There we go. And the gamma subunits are blocking alpha and beta so that they don't work right now, which is a terrible thing, right? So let's activate them. And the G protein alpha is actually going to do that for us. It's going to pull this away. So G protein alpha is going to pull the gamma of the phosphodiesterase away from the alpha and beta of phosphodiesterase and activating it. Activating the phosphodiesterase. There we go. Fine. And so what's phosphodiesterase going to do? Why it's going to do what it always does. It's going to take cyclic nucleotides and turn them into no longer cyclic nucleotides. This particular phosphodiesterase is going to be a cyclic GMP phosphodiesterase.